Hi students, good evening everyone. I hope all are doing well. Welcome to Infinity Learn by Sri Chaitanya. This is me Surya, your chemistry faculty from Infinity Learn. Hi Durgeshwar, good evening. Welcome to the session. I hope I'm perfectly audible and visible to each and everyone present over here. So those who are watching the live, just mark your attendance here. So finally, we are moving to the last part of the same chapter, chemical bonding. It is about the hybridization. We have already discussed about the valence bond theory, right? So hybridization is another part of the valence bond theory. We will be dealing with the different types of hybridization. First, we need to focus about what is the meaning of hybridization, what is the main points about the features of the hybridization. Then we need to talk about the types of hybridization, mainly focusing about the sp, sp2 and sp3 hybridization along with their examples. So let's start our first topic here. What do you mean by hybridization? Do you have any idea about the hybridization? So in the case of valence bond theory, we have already seen about the overlapping of orbitals, right? As contradictory to the valence bond theory, we will be given the another concept of the hybridization known as it is the intermixing of orbitals. So we can just define the hybridization process as the intermixing of atomic orbitals of slightly different energies. They should be having almost similar or slightly different energies, resulting in the formation of new set of orbitals known as the hybrid orbitals. So is there anyone asking about the hybridization? You can just define the hybridization as the it's a process of intermixing of orbitals having the almost similar energy to form the new type of orbitals known as the hybrid orbital. That will be the exact definition for the hybridization. I hope you understand about the concept of hybridization. Is that clear? So in order to satisfy the condition for the hybridization, there also should be some other points we have to keep in mind that is about the features of the hybridization. So as we already know, as a part of a hybridization, new type of orbitals are forming. They are known as the hybrid orbitals, right? So that is given here. The new orbitals formed during the hybridization are called hybrid orbitals. These are the features of hybridization, first one. Then second one, the number of hybrid orbitals is equal to the number of atomic orbitals that get hybridized. For example, if I am taking two atomic orbitals, right? AO stands for my atomic orbitals. If they are undergoing hybridization, what will be the total number of hybrid orbitals? It will be similar, right? They will be forming two hybrid orbitals. Is that clear? For example, if you are taking n number of atomic orbitals for the hybridization, you will be getting n number of hybrid orbitals as the product of hybridization. That is given in the second point. Then, the hybridized orbitals are always equivalent in energy and shape. Let us discuss in detail while discussing about the sp, sp2 and sp3 hybridization, about the energy part. Then, the hybridized orbitals are more effective in forming stable bonds than the pure atomic orbital. You will get an idea when we are discussing about the sp hybridization or sp2 or sp3 hybridization. So, in the exam point of view, you need to focus these 5 points regarding the features of hybridization. I hope you are getting my point, right? Then what about the last point? These hybrid orbitals are directed in space in some preferred direction to have a particular, minimum repulsion between the electron pairs and the stable arrangement. Simply it is saying about that depending upon the hybridization, they will be having different shapes or geometry. Let us see in detail. Is there any doubt regarding the features of hybridization? The atomic orbitals will be having almost similar energy, will be undergoing hybridization to form same number of hybrid orbitals, and they will be defined the shape of the molecules. That is the basic idea about the hybridization. Now let us discuss about the conditions for the hybridization. So as we already know, when we are discussing about the overlapping concept, you have already seen there should be having at least one unpaired electron, right? Similarly, in the case of hybridization also, the orbitals present in the valence shell of the atom are hybridizing. So for example, if you are taking any of the example, we will be focusing only on the valence shell of the particular element. Clear? Then the orbitals undergoing hybridization should have almost equal energy. That is the main point about the hybridization. Then the promotion of an electron is an essential condition prior to hybridization. While discussing about the structure of different molecules, you will be get a proper idea about these 3 points given here. Is there any doubt regarding the points given here? When we are discussing about the hybridization part, valence shell of the element should be focused on the hybridization, and they will be having almost a similar energy. If you want to excite the electron, there will be the excitation of electron is also possible for the hybridization. These are the 3 important conditions regarding the hybridization part. Now we need to focus about the different types of hybridization. There will be 5 or 6 different types of hybridization possible. One is sp, sp2, sp3, sp3d and sp3d2. This sp3d and sp3d2 we will be discussing the higher classes only. In order to get a proper idea about the hybridization, we will be discussing mainly about the sp, sp2 and sp3 hybridization. Ready? Let's start with the first hybridization given here, that is sp hybridization. So what will be which of the orbitals will be undergoing hybridization here in the case of sp hybridization? The name itself is giving the idea about the atomic orbitals present over here. So which are the different atomic orbitals will be undergoing hybridization in the case of sp hybridization? sp hybridization, right? One s orbital and one p orbital of an atom to produce two new sp hybridized orbital is known as the sp hybridization. So we have already mentioned the features, right? If you are taking 2 atomic orbitals, you will be getting 2 hybrid orbitals. So here I am taking one s orbital and one p orbital, total 2 atomic orbitals, right? So they will be producing 2 new sp hybrid orbitals known as the sp hybridization. Clear? So while discussing about the shape of this molecule, you can say that it will be having a shape of linear. Linear means it will be having a bond angle of around 180 degree. So that's why this hybridization is again known as linear or diagonal hybridization, right? Diagonal hybridization. So again repeating the same, because s and p orbital will be having almost same energy, so they will be undergoing hybridization to form the sp hybridized orbital having the almost similar energy. Let us see one example here. So the last class we have already discussed about the shape of orbitals, right? So this is our s orbital, this is our p orbital, this p orbital along the x-axis, so this will be the px orbital, right? So this is a spherical shape, this is a dumbbell shape. When they are undergoing hybridization, they will be forming the linear shaped sp hybrid orbital. Is that clear? Linear means it will be in the straight line, so bond angle will be 180 degree. So this is about the case of sp hybridization. Now you can say that if you are taking about the s and p character over here, it is out of 100%, it is 50% s character as well as 50% p character, right? So this is given here, 50% p orbital character and 50% s orbital character is present in the case of sp hybridization. This is the shape of sp hybridized orbital. So they will be forming corresponding linear shape with bond angle of 180 degree. So this is all about the case of sp hybridization. Now let us see one example regarding the sp hybridization. So I will be taking the example of beryllium chloride, BeCl₂. So what will be the electronic configuration of beryllium? We have already completed our periodic table. We have already know the atomic numbers of different elements. So if I am asking about the case of beryllium, beryllium will be having the atomic number of 4, right? Which means 1s2, 2s2 is the electronic configuration of the beryllium. Is there any doubt? So while discussing about the conditions for the hybridization, I have already mentioned one point that there will be the excitation of electrons will be happen, right? For example, if I am taking beryllium in the ground state configuration, it will be 1s2, 2s2. If I am representing in the box, this is a 1s orbital, this is a 2s orbital, there will be 2 electrons present, right? In the case of 2s orbital, is again 2 electrons are present. This is the representation. Now, if it is undergoing the excitation means beryllium in the excited state. What is happening here? This is the 1s2, 2s, 2p. 2p means 3 orbitals are present at px, py and pz. So 2 is already present here. One of the electron from 2s orbital will be excited to 2py orbital, 2px orbital, right? Is the point clear to everyone? This is the ground state electronic configuration of beryllium. In the case of 2s orbital, there will be 2 electrons are present. Then at the excitation stage, one of the electron from the 2s orbital will be goes towards the 2px orbital. So they will be forming the sp hybridization. I hope you understand how they are forming sp hybridization, right? We have already seen in the case of beryllium, they will be undergoing sp hybridization. Now, in order to complete the molecule, there will be 2 chlorine atoms are present, right? So we need to focus about the case of chlorine atoms also. Now let us see here. Okay, chlorine, as we already know, is again repeated here the same thing. Beryllium atom, one of the 2s electron goes to the 2p orbital. So this will be the corresponding box diagram for the sp hybridized orbital, right? This is a sp hybridized orbital. Now let us focus about the case of chlorine. So chlorine, as we already know, atomic number is 70, right? If you write down the electronic configuration of chlorine, it will be 1s2, 2s2, 2p6, 3s2 and 3p3. If I am elaborating the 3p3 orbital here, right? This will be the 3p3 means three px1, 3py1, 3pz1, right? This will be the complete electronic configuration of in the case of chlorine. So as we already know, whenever we are discussing about the case of hybridization, we need to focus about the valence shell of the particular orbital, right? Particular element. So here the valence shell is the 3pz, right? 3pz. So the pz orbital of the one chlorine atom and one sp hybridized orbital of the beryllium atom will undergo sigma pp bond, or simply known as the spp sigma bond. I hope you understand the case of sp hybridization, right? So what we need to do first we need to identify the central atom in the case of different molecules. So here in the case of beryllium chloride, beryllium is the central atom. So beryllium will be having the general electronic configuration of 1s2, 2s2. So in order to undergoing for sp hybridization, they will be excitation of one electron is happening from 2s orbital to 2p orbital. So these 2s and 2p orbital will be undergoing sp hybridization to form the 2sp hybridized orbital. Then the chlorine will be attaching the chlorine will be having the electronic configuration of 3pz1 here. So one of the 3pz1 orbital will be overlapping here to form the spp sigma bond. Sigma bond stands for the head-on overlapping there. We have already discussed in the last class types of covalent bonds, right? So in the case of hybridization, first one is the intermixing of orbital to form the hybridization. Then after that, the remaining atoms or remaining elements will be undergoing the corresponding overlapping to form the sigma bond. So what will be the final shape of BeCl₂ molecule? This will be the final shape of BeCl₂ molecule. Here it will be the spp sigma bond. Here it is again spp sigma bond. So if you write down the shape of this molecule, it will be BeCl₂ with a bond angle of 180 degree and shape is linear. Is that clear, everyone? So this is about the case of sp hybridization. Similarly, we need to focus about the sp2 and sp3 hybridization along with some examples. So now we are moving to the sp2 hybridization. And some other examples are already given in our textbook about the case of sp hybridization. So if you are asking about the case of BeCl₂, we have already seen, right? So in the case of BeCl₂, 2 sigma bonds are formed there, and there is no any pi bonds are formed there, right? So overlappings are sp_p sigma bond and BeCl bond angle is 180 degree. Now just try to find out the hybridization, how to write down the hybridization of these molecules given here. I have already given in the case of carbon dioxide molecule, 2 sigma bonds and 2 pi bonds are present, right? So as we already know, structure will be C double bond O, which means 2 pi bonds and 2 sigma bonds are present. So it will be having the sp_p sigma bond as well as sp_p pi bond is also present in the case of carbon dioxide molecule. So this table is very important. Maybe you will be getting any questions based on the different molecules having their hybridization and bond angle. So this is very important. So try to find out the hybridization for different molecules. C2H2 we have already discussed in the carbon and its compounds. Ethene molecule, right? Double bonded carbon compounds. We have already discussed about the sp hybridization of, triple bond carbon, right? C2. This is the ethine molecule. We have already discussed in the hybridization part there. Then HCN is also very important. Now we are moving to the second type of hybridization, that is sp2 hybridization. So in the case of sp2 hybridization, it is understood that one s orbital and 2 p orbital will be undergoing intermixing to form the corresponding 3 sp2 hybridized orbital. S1 s orbital plus 2 p orbital will be undergoing hybridization to form total 1 plus 2, 3, right? 3 sp2 hybridized orbital. This is the exact definition for the sp2 hybridization. Now we need to focus mainly on the examples given here. So here it is BeCl₃, right? BeCl₃. So central atom is boron here. Electronic configuration of boron is 1s2, 2s2, 2p1, right? 1s2, 2s2, 2p1. So what we need to do, we need to focus on the sp2 hybridization, right? We need 2 p orbitals there. So what I am doing here, it will be undergoing excitation, right? So during excitation, one of the electron from the 2s orbital will goes to the 2py orbital. So it will be forming 2s orbital here. Then the remaining 2 electrons are present in 2px and 2py. 2p set is empty here. So totally they are forming 3 sp2 hybridization. 1 s orbital, 1 2s orbital and 2 p orbital, but one is px orbital and py orbital. So it will be undergoing sp2 hybridization. I hope you understand. That's again given in words here. Excited electronic configuration of boron is 1s2, 2s1, 2px1, 2py1, 2pz0. It is expressed in the case of diagram here. Now the remaining part is already given here. It will be one orbital is again present here, so it will be forming sp2 hybridization. Now as we already know, in the case of BeCl₃ molecule, 3 chlorine atoms will be undergoing overlapping there, right? So what is electronic configuration of chlorine again? We have already seen 3s2, 3p5, so 3px1, 3py1, 3pz1, right? So 3pz1, the valence shell will be undergoing overlapping with the sp2 hybridized orbital of boron to form the sp2p sigma bonds. Clear? Finally, the shape of this molecule will be, this is our s orbital. This will be undergoing px and py. They will be undergoing the sp2 hybridized orbital. These are the 3 sp2 hybridized orbitals. Then after that, pz orbital of the chlorine will be undergoing overlapping to form the particular shape known as the trigonal planar shape with a bond angle of 120 degree. Is that clear? This is the shape of sp2 hybridized orbital. This sp2 hybridized orbital will be overlapping with the pz orbital of chlorine to form corresponding sp2p sigma bonds. So total BeCl₃, it means BeCl₃ sigma bonds are present there with the bond angle of 120 degree and the shape is trigonal planar. Is there any doubt regarding the shape of BeCl₃? Okay, finally we are moving to the next type of hybridization. So again, there are some of the examples for the sp2 hybridization also. BeCl₃ we have already discussed. So try to find out the shape of sp2 hybridized orbital for the SO2, SO3, C2H4 and HCHO. C2H4 means we have already discussed in the case of ethene molecule, right? Double bonded carbon compound we have already discussed. Number of sigma bonds. This is the sigma bonds, this is the pi bonds. So they have already given the examples for different sp2 hybridized orbitals. So take it as a homework. Try to find out the hybridization shape of these molecules given here. Hi Suhana. Okay, what is the state of graphite? Now we need to focus about the case of sp3 hybridization, right? sp3 hybridization. So as we already know, in the case of hybridization, there will be the intermixing of orbitals happening, right? I have no idea about the case of graphite. Graphite is the allotrope of carbon, right? So in the case of sp3 hybridization, again, one s orbital and 3 p orbitals will be forming. 4 sp3 hybridized orbital is known as the sp3 hybridization. Repeating here, 1 s orbital and 3 p orbitals to form 4 new sp3 hybridized orbitals known as sp3 hybridization. So here in the case of shape of this molecule will be tetrahedral hybridization. So this is again known as a tetrahedral hybridization. Okay, if you are talking about the shape of this molecule, this is a 1s orbital, right? This is one of the s orbital. This is the px, py and pz orbital. When they are combining, when they are undergoing intermixing, they will be forming a shaped molecule known as the sp3 hybridized orbital. So this will be the shape of one sp3 hybridized orbital. In total, 4 sp3 hybridized orbitals are formed there. So again, bond angle is 109 degree 28 minutes. This is the bond angle for the tetrahedral shape. And as we already know, sp3 out of 100%, 25% is s character and 75% is p characters. Now we need to focus about the example of sp3 hybridized molecule. So I think we have already discussed in the case of methane, right? In the case of carbon and its compounds, this is a single bonded carbon compound known as the methane. So if you are finding the hybridization of CH4 molecule, it is understood that it is sp3 hybridization, right? sp3 hybridization, which means carbon will be undergoing sp3 hybridization. So we need to focus about the electronic configuration of carbon, which is given here. Yes. Carbon is having atomic number 6, right? So 1s2, 2s2, 2p2. So I am returning here it is 2px1, 2py1 and 2pz0. So in order to undergo the sp3 hybridization, we need 3 p orbitals, right? So we need 3 p orbitals. So what we are doing here, in the excited state of carbon, it is understood that 2px and 2py1, right? So one of the electron from the 2s orbital will be excited to form the 2pz orbital here. So this is again 2s, 2px, 2py and 2pz. So what we are forming here, total these s orbital and 3 p orbitals will be undergoing intermixing or hybridization to form the sp3 hybridization. Is that clear? So the same point given here, the carbon atom, one of the 2s electrons will be goes to the 2p level orbital. So they will be forming the 2px1, 2py1 and 2pz1 configuration. So undergoing sp3 hybridization. Now in the case of CH4 molecule, remaining 4 atoms are hydrogen atom, right? So as we already know, in the case of hydrogen atom, electronic configuration is 1s1. 1s1 means this is the valence shell itself. So again, the 1s1 orbital of the hydrogen atom will start overlapping with the sp3 hybridized orbital of the carbon to form methane molecule. I hope you understand. This is the shape of sp3 hybridized carbon atom. So if they are doing the overlapping here, 4 hydrogen atom, I mean 1s1 orbital of the hydrogen atom will be undergoing overlapping to form the sp3 s sigma bond here. So they will be forming the CH4 molecule with a bond angle of 109 degree 28 minute, which is known as the tetrahedral shape. Is there any doubt regarding the hybridization of CH4 molecule? We have already discussed about the sp2, sp and sp3 hybridization in the case of carbon compound also. So it is very important in the case of hybridization, how to find out the hybridization of different molecules. Then two more exceptional cases there in the case of sp3 hybridization. As we already know, the hybridization shape of the molecule will be depending upon the hybridization, right? So in the case of sp hybridization, if you are asking about the sp hybridization, shape of the molecule is linear, right? Linear with bond angle of 180 degree. Then if you are asking about the case of sp2 hybridization, shape is trigonal planar. And bond angle is 120 degree, right? 120 degree. And last one, it is sp3 hybridization. Shape is tetrahedral. Bond angle is 109 degree 28 minute. Again, some exceptional cases are there if you are asking about the case of water molecule. Hybridization is sp3. There is a trick to find out the hybridization. No, it's not in the CBSE syllabus. It is completely in our grade 11. So we have already completed the CBSE syllabus. That's why I'm just taking the hybridization part over here. Just to give a brief idea about the hybridization part, it will be helpful for you to get an idea in the grade 11 class. In the case of water molecule, it is again sp3 hybridization, but the shape will be different because it is the bend shape or V shape. Similarly, if you are asking about the case of ammonia molecule, NH3 molecule, right? It is again sp3 hybridization, but the shape is pyramidal. With a bond angle of 107 degree. So this is all about the part of hybridization. I hope you understand. We have already discussed what you mean by the hybridization, right? So hybridization is the simply intermixing of atomic orbitals will be having almost similar energy. So depending upon the atomic orbitals forming, there will be same number of hybrid orbitals are forming. So there will be 3 types of hybridization. Mainly 5 types of hybridization are possible, but we need to focus mainly on the sp, sp2 and sp3 hybridization. We have already seen many examples for the sp, sp2 and sp3 hybridization. And their bond angle as well as shape is very important. Depending upon the hybridization, different molecules will be having different shapes. Is there any doubt regarding the hybridization? Now we need to focus some questions here. So here is the first question. Which type of hybridization is present in methane molecule? So what will be the answer for this question? Molecule is already given here. Methane molecule. Which type of hybridization is present in the case of methane molecule? At least give me random guesses. Options are already given here. Whether it is sp hybridization, sp2 hybridization, sp3 or d sp2 hybridization. We have already discussed the last case, right? Methane means CH4 molecule. Carbon compound containing only single bond. So one carbon compound, methane, right? So methane will be having the hybridization of sp3 hybridization. If you are not familiar with the shape of this molecule or the hybridization, there is a simple trick to find out the hybridization, that is about the steric number concept. So steric number is equal to the total number of sigma bonds. So the number of sigma bonds plus number of lone pairs. So as we already know, in the case of CH4 molecule, 4 hydrogen atom will be forming 4 sigma bonds with the carbon atom, right? So simply the number of steric number for the corresponding molecule is 4 only. 4 plus 0, that is equal to 4. So if you are having the steric number is equal to 4, the particular hybridization will be sp3 hybridization. So similarly, if you are find down the steric number for the sp hybridization, steric number will be equal to 2, and for sp2 hybridization, steric number is equal to 3, and for dsp2, steric number is equal to 4 again. Clear? Here is the next question. Which of the following molecules is the central atom sp hybridized? Use the steric number concept, find out the steric number. If you are getting the steric number is equal to 2, obviously the particular molecule will be having the hybridization of sp hybridization. So if I am considering we can start from here. If I am considering the CH4 molecule, steric number is equal to total number of sigma bonds. In the case of carbon, it will be forming 4 sigma bonds. So steric number is equal to 4, sp3 hybridization. Then again, in the case of BF3 molecule, right? BF3 molecule, as we already know, boron will be having 3 valence electrons. So steric number is equal to 3. 3 means sp2 hybridization. In the case of NH3, nitrogen will be having 1 lone pair there, right? So 3 sigma bonds plus 1 lone pair, that is equal to 4 again. So 4 stands for sp3 hybridization. Again, this is the exceptional case. Shape will be pyramidal. Now, if you are focusing about the BeCl₂ molecule, if you are finding the steric number concept, total 2 sigma bonds are formed between BeCl₂ molecule, right? So 2 is equal to here. So that will be sp hybridization. So BeCl₂ will be the correct answer here. Here is the next question. What is the hybridization of the nitrogen atom in ammonia? Again sp3, right? So exceptional cases are in the case of sp3, one is ammonia, shape is pyramidal, and another one is water molecule, right? Because of the presence of lone pairs, shape will be changes from tetrahedral to bend shape in the case of water molecule. Okay, there is one subjective question. Define hybridization. Name the types of hybridization involving s and p orbitals. Give one example for each. So we have already discussed the concept of hybridization, right? So hybridization is defined as the process of intermixing of atomic orbitals of nearly equal energy to form the new hybrid orbitals. So we need to focus on the sp and orbital based hybridization, right? So sp hybridized orbital you can see here. If I am asking about the sp hybridization, one s orbital and one p orbital will be undergoing intermixing to form the 2sp hybridized orbital. Example is given here, BeCl₂, right? BeCl₂ and C2H2. BeCl₂ we have already seen. C2H2 molecule we have already seen in the last chapter, I think, carbon and its compound. Then again in the case of sp2 hybridization, one s orbital and two p orbital will be forming 3 sp2 hybridized orbital having a shape of triangular planar with a bond angle of 120 degree. Examples are BF3 and C2H4 molecule. Then the last one, sp3 hybridization, 1s and 3p orbital will be undergoing intermixing to form 4 sp3 hybridized orbital with a shape of tetrahedral and bond angle is 109 degree, 109.5 degree. Examples are CH4 and NH3 molecule. And one more example is the water molecule. Okay, this is all about the hybridization part. So we have already completed our chemical bonding chapter. We have started from the basics of the chemical bonding. What do you mean by the chemical bonding? What are the different types of bonds? We have discussed about the ionic bonds, covalent bond. We have seen the covalent compounds as well as ionic compounds. Then we have seen valence bond theory, right? Valence bond theory in the last class. Now we have discussed about the hybridization part also. So I am just giving a brief idea about the chemical bonding chapter. When you are discussing in the grade 11 classes, you will get a proper idea about the complete chemical bonding and molecular structure. In that chapter, we will be discussing about the molecular orbital theory, PSEPR theory in detail. So I hope you understand. In the next class, I will be coming back with the questions based on the chemical bonding. We will try to revise the complete chapter. So there is a gentle reminder about the SCORE examination. Sri Chaitanya Academy is providing an international level scholarship exam. Exam will be conducting on September 28 and October 12. The deadline for registering the exam is September 26. You will be getting, link will be provided in the description. You need to register now. If you are missing any, is there anyone missed the opportunity here, you can just register now. Deadline is for September 26. Exam will be conducted on September 28. There will be online as well as offline. Exam will be there. Depending upon the offline center, you can go with the offline examination. So again, link will be provided in the description. Just register now. So that's all about from my side for today. We have already completed the chemical bonding chapter. I hope you guys understand the chemical bonding and the molecular structure chapter. If you really like the section, hit the like button, share this particular session to your friends also, and subscribe our channel, Infinity Learn 9 and 10 channel. And if you need to get the session PDF, you need to join our Telegram channel, Infinity Learn 9 and 10 Telegram channel. You will be getting the session PDF after every classes there. If you have any doubt, you can ask. Otherwise, we can end the session for today. Okay, then thank you so much all of you. See you in the next class. Bye-bye.